Hi everyone. In recent years, there have been some exciting advancements in what's possible through 3D spatial technologies. Both from a functionality and data perspective, systems are now able to empower us to do more and ultimately make more informed decisions. Planning at DELWP have been able to take advantage of these new capabilities to undertake analysis such as overshadowing impacts, conducting visibility assessments, and calculating solar radiation. Big 3D is the planning group's 3D web mapping platform. Highly accessible, intuitive, and easy to use, it's empowering planners to make more informed decisions about the future of Victoria. Key features as part of Big 3D include visualization of existing built form alongside development activity models, ability to sketch up proposed buildings, and analysis tools to undertake functions such as line of sight or viewshed reviews. Today, I want to briefly demonstrate some of the ways Vic3D is assisting our planners to work more effectively and undertake analysis more efficiently. One of the primary functions of the 3D platform is to provide a mechanism to easily visualize proposed development across the city. When a building model is submitted to the department, it's automatically published to the platform to make it easy to analyze within the existing context. And when multiple versions of a proposed development are submitted, planners can easily review the changes that have been made between the models. But when building models aren't made available to us, planners need an efficient method to quickly mock up proposed developments from within the interface. This is easily supported through the sketch function, which allows users to create a building quite easily with different segments and different setback configurations. Once complete, these buildings form part of any analysis undertaken within the viewer, including the impacts of overshadowing. In this scenario, we want to see if the proposed building will violate any restrictions. For instance, building height limitations due to the shrine vista. In this case, we can clearly see that it violates that height constraint. There are also scenarios where we need to conduct visibility assessments for existing and proposed buildings. Planners can assess the visibility from or visibility of a proposed development within the existing built form. We can look at, for instance, the level of visibility for the Yarra River from this proposed building. The analysis shows that there is a higher level of visibility over the course of a single day for the higher levels, marked by an increased intensity of the shading. Analysing solar radiation calculations empowers our planners to review buildings' potential for solar panels installation. Vic3D provides the ability to review the solar radiation both for the existing built form and how that changes with the introduction of a newly proposed building. This will help determine the ideal location for solar panels and the impact of existing solar infrastructure from the new building. When looking at the solar radiation after including that new proposed building, we can see the impact of the introduced shadowing on the buildings in front of it, which is lowering their solar potential. And finally, planners can solely focus on the potential shadow impact of a proposed development on the surrounding buildings. In this scenario, we can assess the existing cumulative shadowing over the course of a single day, then compare with the cumulative shadow after removing the existing building and introducing the new development. Unfortunately, this doesn't easily highlight what's been introduced from a shadowing perspective, but we can then pivot to what is the shadow difference between the pre and post development. This makes it simple to see which areas are affected by the newly introduced shadowing and the intensity or duration of this over the course of a day. Looking ahead, we're excited to see what's possible through the integrations between spatial and gaming engines. We have fantastic data, we have powerful tools. Now we want to harness the potential of gaming engines such as Unreal and Unity to develop impressive visualizations. There have been some great advancements in this space quite recently, which is going to support great live linkages between the technologies moving forward. Instead of having disparate solutions, the potential to stream spatial data directly onto the visualization platforms opens up so many opportunities. Working with partners such as Aerometrics to investigate what's possible in this space, like what you can see on the screen right now, we believe this is going to change the way that we undertake planning and set us up for the future. I would welcome any communication around knowledge sharing or collaboration opportunities. So feel free to reach out via my email address on the screen. Thank you for your time and letting us show you how we're working more effectively within planning. Thank you very much.